Welcome to the Deep Dive, the show tailor-made for you, the learner. We're here to take complex, high-stakes source material and, well, distill the crucial knowledge, the insight, and those surprising connections, turning information overload into informed perspective.
And today, we are jumping into one of the most, I think, profound questions humanity ever asks itself. It's about the search for extraterrestrial intelligence.
Yeah.
We always frame it as, are we alone?
Right.
But our source material today asks a much, much sharper question.
Exactly. We are deep diving into the metatheoretical brilliance of Stanislav Lem's Summa Technologiae, and specifically his chapter on cosmic civilizations. And, this isn't science fiction. Lem isn't giving us plots here.
No, not at all.
He's offering a critique of the very limits of scientific possibility, and maybe even the limits of our own imagination.
We're really examining a core paradox.
Yeah.
Let's say hyper-advanced life using what he calls astroengineering on a scale we can barely comprehend. Let's say it was out there. Our established rules of scientific discovery, our methodological backbone, the famous Occam's razor, might actually prevent us from even recognizing it.
Our mission today is sort of threefold. First, we're going to explore the ultimate possible wonders that these cosmic architects might create. We're moving way beyond just listening for radio signals.
Yeah, way beyond.
Second, we have to understand why science is fundamentally structured to default to natural explanations, even when it sees the most bizarre phenomena imaginable.
And then finally, we're going to ask the really tough question. Are our own ingrained anthropomorphic biases, the way we define progress and power, are they fundamentally blinding us to what advanced intelligence might actually look like?
And it forces us to consider that maybe the lack of a signal, maybe that is the deepest possible message.
A profound silence.
Exactly. And to start this whole journey, we are kicking off with what might be the ultimate calling card of a truly vast, high-level civilization, manipulating the furnace of a star with just a few million tons of an incredibly rare element. So yeah, let's unpack this.
Okay, so this concept of miracles, let's just, put a pin in that right away. When Lem uses this word, we are not invoking the supernatural.
No, absolutely not. That's a crucial distinction to make right up front. He's drawing on this intellectual tradition, maybe even the playful audacity of the great Russian astronomer I.S. Shklovsky.
Right.
Shklovsky was the one who suggested these possible wonders that advanced astroengineering might create. And these are phenomena that are so far outside the accepted envelope of how stars or galaxies work.
That the natural explanation it breaks down. It fails immediately.
It fails completely. And the audacity of the scale is what I think first grabs you. One of the first suggestions is the deliberate manipulation of cosmic events on the grandest possible scale. For instance, artificially caused supernova explosions.
I mean, just stop and think about that for a second. The energy involved, it's almost impossible to get your head around. A supernova is this violent, catastrophic collapse of a massive star. In seconds, it releases the energy equivalent of what our sun will emit over its entire 10 billion year lifetime.
The entire lifetime.
The entire lifetime. So for a civilization to be able to deliberately trigger that collapse, maybe to harvest some exotic, heavy elements that are created, or maybe just to clear out a region of space, that speaks to a level of mastery over fundamental physics that is, frankly, terrifying.
It changes everything. It shifts stars from being these random, natural things in the sky to being controllable tools. They're in the toolbox of an advanced society.
Right. But that, that remains a pretty grand hypothesis. The second example he gives is where the idea becomes really specific and quantifiable. It's tied directly to things we can actually look for with telescopes.
And this is the technetium calling card.
This is where it gets really interesting. Lem highlights the idea of finding the spectral lines of the element technetium in the radiation of certain rare or peculiar stars.
And the claim is, it's a bold one, the claim is if we observe these lines, that would be it. That's the definitive, undeniable proof of intelligent engineering.
The smoking gun.
And the reason for that certainty isn't just a guess. It lies in the element's nuclear characteristics, right? Tell us about technetium. Why is it so special?
Okay, so technetium, element 43 on the periodic table, is essentially unique. Here on Earth, we have to synthesize it. We make it in reactors or particle accelerators. It doesn't occur naturally in any stable form.
It's man-made.
Entirely. But more importantly, it's inherently unstable. That means it undergoes rapid radioactive decay. Its longest-lived isotope, which is technetium-99, has a half-life of only about 211,000 years.
Okay, so in the context of cosmic time, where stars live for billions of years and even, the remnants of a supernova last for millions, 200,000 years is nothing.
It's a blink of an eye. It's a rounding error. So for a scientist observing a star, if they see the spectral signature of technetium, they know two things instantly. One, it must have been produced very, very recently, within, say, the last few tens of thousands of years.
And two,
it could not possibly have been created when the star was first formed.
Right.
Not in its initial cycle, because it would have completely decayed away billions of years ago.
which leaves only one possibility.
Only one. The element must have been introduced or doped into that stellar furnace from the outside and recently by an external agent.
By astroengineers.
By astroengineers.
Yeah.
It is the ultimate intentional signal.
What I find so brilliant about that is the implication of deliberate, calculated action. They didn't just dump some stuff into a star. They would have had to synthesize an unstable element and then inject it, specifically to create an unmistakable but also temporary flag. They're using nuclear instability as a clock.
That's the deepest insight, I think. It's not just that they manipulated matter. That's impressive enough. It's that they used time and decay as part of the signaling mechanism itself. It's a message that says, we were here, and we were here recently.
And Lem, drawing on Shklovsky, he points out this delicious little paradox of scale that makes it even more compelling.
Yes, because we think of vast cosmic engineering, we think of, Dyson spheres, massive resource expenditure.
Curving planets around.
Right. But Lem notes that the actual quantity of technetium you would need, the amount required to make its spectral lines appear strongly enough in the star's radiation to be visible from light years away, is, astronomically speaking, negligible.
And how much is that?
Only a few million tons.
Only a few million tons. I mean, that is the ultimate nugget for you, the listener. The evidence for a galactic intelligence might not be some giant megastructure. It could be the spiroscopic equivalent of a footnote.
Exactly. A statistically insignificant amount of mass, but it carries the most profound weight of deliberate intention.
And that highlights the difference between, say, an accidental byproduct of technology, like waste heat from a Dyson sphere,
Sure.
and a calculated, finely tuned signal. Those few million tons of technetium suggest a very subtle, very sophisticated technique.
It does. Which, of course, leads to the natural follow-up challenge that Lem immediately poses.
Which is?
Where did the astroengineers store those few million tons of highly volatile, radioactive, synthesized technetium before they injected it into the stellar atmosphere?
Right. It's not like you can just leave it in a shed.
Not at all. That complexity, that single question, immediately expands the scope of the technology we have to imagine. It forces us to consider the vast infrastructure that's needed just to produce the calling card.
So it's not just the ability to synthesize this element.
No, it's the ability to contain it, to transport it across the solar system, and then deploy it with incredible precision into a star. It moves the whole discussion from a single act of doping to viewing the entire star system as an active construction site.
And this idea, this notion of stars as kind of construction sites, it expands even further into the idea of stars as factories.
Right. If you move beyond just simple element doping, the sources suggest that even the quote-unquote natural process of star formation itself could be interpreted through this lens of astroengineering.
How so?
Well, think about where the building blocks of life came from. The heavy elements, carbon, oxygen, iron, everything you need for complex chemistry, for planets, and for us. They were forged in the cores of the first generation of massive stars.
Right, through nucleosynthesis.
Exactly. So in a way, you can view the stars themselves as the universe's original and most powerful high-tech converters or accelerators. They're designed by nature for the production of these necessary heavy elements.
So if a civilization decides for its long-term survival that it needs a specific mix of elements, maybe more gold or more uranium, manipulating star formation becomes the ultimate form of resource management.
They're optimizing the universe's natural processes for their own ends. They shift from being simple users of the universe to being active managers of its evolution.
So for a scientist who's out there looking for evidence, these engineered stellar events, the purposeful supernova, the technetium flag, they represent the most powerful, explicit pieces of evidence you could possibly imagine.
They are true violations of the natural historical record of the cosmos.
But, and this is the huge pivot point of Lem's entire argument, these ideas, these arguments for intervention, as breathtaking as they are, they inherently violate the core principle of scientific methodology. the very principle that filters all discovery. So now we have to turn to the gatekeeper that forces scientists to be skeptical even when they're presented with what looks, for all the world, like a miracle.
This methodological conflict has to be fully understood. These astroengineering hypotheses, they violate this presumption of natural explanations. We really need to understand why science is not allowed to jump to the conclusion that aliens do it, no matter how neat and tidy the evidence might seem.
So, why is it? When a scientist is faced with a truly bizarre, unexplained cosmic anomaly, why is the first rule not, it must be extraterrestrials? The answer is, it's rigorous. It's deeply rooted in the philosophical basis of all modern science.
It's Occam's razor.
Occam's razor. And this principle, it's not just, a preference for simplicity. It's an intellectual mechanism. It's designed to ensure the economy of thought and, crucially, the systematic unification of all knowledge across all disciplines.
It's the silent editor in every scientific paper, ensuring methodological rigor.
The Latin thesis, which I think really captures the severity of the principle, is entia non sunt multiplicanda praeter necessitatem.
Entities should not be multiplied beyond necessity.
What does that actually mean in practice?
It means that when you're building a hypothesis to explain some phenomenon, you should introduce the absolute minimum number of basic concepts or entities that are required. So, if phenomena A and B can be explained by an existing law C, you don't just invent a new force D unless law C catastrophically fails to explain the data.
And the consistent application of this, it isn't just about writing elegant theories. It's really the engine that drives all of science toward unification.
It is. It pushes us to reduce diverse phenomena, whether you're talking about chemical reactions, planetary orbits, or biological processes, down to the most general basic concepts. And that almost always means the laws of fundamental physics.
So introducing a new concept, a new entity, is a huge theoretical cost.
A massive cost.
Yeah.
It's only permissible in those very exceptional cases where its absence puts one of the few foundational laws of physics, those pillars that all other knowledge rests on, under some kind of existential threat.
And Lem provides the classic, perfect example of a required entity, an entity that had to be invented.
The neutrino.
The neutrino. Let's spend some time on that because it beautifully illustrates both the power and the strict limitations of the razor. What was the crisis that made the neutrino necessary?
The crisis happened back in the 1930s. Physicists were studying a process called beta decay, where a neutron in an atom's nucleus converts into a proton and an electron. Pretty standard stuff.
Okay.
But when they measured the total energy and momentum of the particles after the decay, they noticed something that was, for a physicist, terrifying. The total energy and mass after the decay was consistently less than the mass before the decay.
So energy was just vanishing into thin air.
Exactly. And for a physicist, that is a complete disaster. The law of conservation of energy and mass is arguably the most sacred pillar of physics. If that law fails in one single experiment, the entire edifice of physical law just collapses.
So they were faced with a choice.
A terrible choice. Either declare that this fundamental law of the universe was in fact wrong, or introduce a new entity to save it.
And that's when Wolfgang Pauli stepped in?
He stepped in to save the foundation. He hypothesized the neutrino. He argued that there must be this invisible, massless, chargeless particle that was carrying away the missing energy and momentum.
And the introduction of this ghost particle, it wasn't whimsical, it wasn't just a fun idea.
No, it was absolutely necessary to save the law of conservation. It was the most economical path forward for all of physics. And then, decades later, experiments finally confirmed the neutrino's existence, completely validating the methodological necessity of Pauli's move.
Okay, that makes the cost of introducing an entity really clear. It has to preserve a higher, more foundational principle. So now let's contrast that with some of the entities that were eventually rejected that failed the razor's test.
A great example is from biology. For centuries, people advocated for concepts like entelechy or vital force to explain life.
The idea that there's some kind of magic spark of life.
Basically, yeah. These theories suggested that living matter was governed by some mysterious non-physical element, a unique life stuff that couldn't be reduced down to known chemistry and physics. It was an entity introduced to explain the gap between the living and the non-living.
But it turned out to be unnecessary.
Completely unnecessary. As biochemistry and molecular biology advanced, they systematically showed that life processes, metabolism, replication, heredity, could be explained, and with increasing detail, through standard chemical kinetics, thermodynamics, molecular structure, the vital force was revealed as superfluous. It was unnecessary theoretical baggage.
So it's not that the vital force was proven false exactly, it's that it was just proven unnecessary to explain the data we were seeing. The principle of economy of thought just, it eliminated it.
And you see a similar logic with the concept of a supernatural act of creation in scientific cosmology or biology. Now, science doesn't reject this because scientists can prove there's no creator.
Right, it's not a statement of proof.
No, it's a statement of methodology.
Mhm.
The idea is rejected because biogenesis, evolution, the emergence of consciousness, these are all things that can be approached and are being actively researched without introducing that additional unprovable entity. It fails the economy test. The razor demands that we seek the natural explanation first, as far as it can possibly take us.
And this brings us, finally, all the way back to the cosmic search. When an astronomer observes some unexplained, fact, highly focused radio emissions or, massive complex energy structures near a distant galaxy, the scientific duty is clear.
The scientist is observing facts that are not yet explained by our known theoretical models. That's it. But they are, as a matter of principle, methodologically forbidden from concluding. This is incomprehensible to us, therefore it is a manifestation of intelligent beings.
That seems like an almost tragic restriction, especially when we're actively spending time and money searching for those beings. Why must the intelligence hypothesis be rejected, even just provisionally?
It's the ultimate form of scientific risk management. Problem is this. If you accept reasoned intervention as the cause, you prematurely halt all attempts at finding a natural explanation.
Ah. If intelligence did it, the search for a law of nature is over.
It's over. And that's the fundamental problem. What if the phenomenon is actually a manifestation of a new, unknown natural law? A law we haven't discovered yet, maybe involving exotic physics or dark energy interactions? If you accept the intelligence hypothesis, science stops investigating, and you miss a fundamental discovery about how the universe itself actually works.
The stakes are incredibly high. It's the difference between finding a new law of nature and just, classifying something as an artifact. And the source gives that beautiful, really memorable analogy to illustrate this choice.
The beach analogy.
The beach analogy.
Imagine you're a geologist, and you're walking along a completely deserted stretch of coastline, and you find a large number of heaps of stones, all lying at perfectly regular, symmetrical intervals.
Your first thought can't be someone was here.
As a scientist, it can't be. Your immediate professional scientific inclination must be to assume this is some unknown manifestation of hydrodynamics, or tidal forces, or geological forces. You'd start building complex hypotheses about microseismic activity or wave diffraction patterns. You might be on the verge of discovering a new, unifying law of physics.
But then you find a note washed up on the beach, and it says, "I was here yesterday, I was bored, and I placed these stones in a pattern for fun."
The moment you gain that knowledge, that this arrangement is the product of reasoned intervention, all of your geological, physical, and hydrodynamic investigations immediately cease.
They just stop. The search for a new natural law is instantly curtailed.
You have to stop. There's no law to find.
Let's just sit with that for a moment because it's so important. The search for a new law has to override the search for a designer. It shows that the methodological drive of science is always toward unification, toward universality. A law of physics is universal. It applies everywhere.
But the concept of ETI is inherently a non-universal explanation. It's a local, arbitrary action taken by one intelligence in one place at one time.
So phenomena that deviates from the galactic norm, like that technetium-doped star we talked about, they're almost always going to be ascribed initially to unknown natural forces, not to the intervention of reason.
It's the methodological choice that allows science to advance. And it really highlights the incredible difficulty of the search for ETI. If advanced intelligence is out there, it has to present evidence that is so profound, so earth-shattering, that to ignore it would threaten a foundational law of the universe, much like that original threat to the conservation of energy.
Otherwise, Occam's razor will simply carve it away. So, given that established science is so strictly bound by Occam's razor, the freedom to really speculate on what might be out there, that often falls to the realm of science fiction.
Right, but Lem, who is a master of science fiction, he turns this around and he critiques what he considers one of the mortal sins of scientific fiction.
And that sin is, ironically, the wholesale multiplication of entities.
Exactly. Science fiction, because it's unbound by methodological rigor, often introduces new concepts, new technologies, new forces, just because they sound dramatic or because they're needed to move a plot forward. There's no consideration of necessity or economy of thought.
Let's look at a few high-energy examples of what Lem would consider these scientifically forbidden hypotheses, all based on assumed engineering. Let's start with the mystery of cosmic rays.
Cosmic rays, these incredibly high-energy particles that are constantly raining down on Earth, they're still a very perplexing phenomenon, very difficult to trace back to a single definitive source.
And the forbidden
The
hypothesis.
forbidden hypothesis, the kind of thing you might read in speculative literature, is that cosmic radiation is simply the scattered exhaust product of enormous quantum jets or photon rockets. The idea is that these things have been traversing the galaxy for millions of years, leaving these plumes behind them.
I mean, that requires an unimaginable level of engineering, civilizations that operate on a totally different scale of fuel expenditure and propulsion.
Oh, completely. And the hypothesis tries to be clever. It tries to link two unexplained phenomena together. The logic suggests that since these hypothetical rockets would be moving at near light speeds, their original light emission would be Doppler shifted way down the spectrum, landing in the radio range.
So maybe, just maybe, part of the mysterious radio noise we observe from space is actually the highly scattered exhaust from these millions of years old rocket plumes.
That's a compelling story, right? It links two observations, cosmic rays and radio noise, to one grand entity, the quantum jet civilization.
But why does the razor reject it?
It rejects it because it introduces a massive, entirely unnecessary entity, this quantum jet civilization. When explanations involving natural sources like supermassive black holes, quasars, complex plasma dynamics, all of these are still being actively pursued and refined using known physics. The scientific process demands that you exhaust all known physical laws first.
And we see the exact same conflict with the mystery of runaway stars.
Yeah, runaway stars. We observe certain stars that are being rapidly ejected from their home clusters. They're moving at hundreds of kilometers per second relative to their neighbors.
And there's a natural explanation for that.
There's a perfectly economical one. It's the gravitational slingshot effect that results from a natural supernova explosion. A star goes supernova, the kinetic energy from that explosion flings a neighboring star out of the cluster. Simple.
But the speculative question, the forbidden question is, what if the explosions of those stellar colleagues were artificial? What if they were produced by astroengineers trying to repurpose stellar mass or maybe even weaponize the energy?
Right. If we admit the possibility of artificial stellar explosions, even partial ones, we have multiplied our entities unnecessarily. A strong, elegant, mathematically sound explanation already exists using gravity, hydrodynamics, and known stellar physics. Occam's razor just cuts the intelligence hypothesis away because it carries a much greater theoretical cost.
And this multiplication of entities, it applies perhaps most poignantly to theories of biological intervention. Things like directed panspermia or, alien creationism.
This is a critique that's aimed squarely at a lot of popular scientific and science fiction ideas. The source material directly addresses the notion that life on Earth, or maybe a critical evolutionary leap like the rapid development of early hominids, that it was all due to external intervention. An alien rocket lands, finds conditions are good, and plants the seeds of life.
Either as a deliberate experiment.
Or even as an accident.
Yeah.
We hear versions of this all the time. The story of the accidental slip-up. A star traveler is returning to their rocket and whoops, they drop a test tube full of primitive embryos, which then go on to thrive on the young Earth.
It's a romantic idea.
It's romantic, but the methodological verdict is decisive. These concepts are fundamentally unsound because they violate the Occam principle. And the core issue is that panspermia, even if it were true, is an explanatory failure.
How is it a failure? It explains how life started on Earth.
But does it? It doesn't solve the mystery of biogenesis. It just exports the problem. It kicks the can down the road. If life on Earth came from aliens, where did the aliens' life come from? You're just left with an infinite regression.
So biogenesis, the origin of life from non-life, still needs to be explained somewhere.
It still needs an explanation, which means the hypothesis of the alien visitor is an unnecessary entity that doesn't actually advance our understanding of the ultimate cause.
It's a way to avoid the hard work of solving biogenesis through chemistry and physics here on Earth by just opting for some distant, inexplicable entity instead.
That's it, exactly. Since the emergence of life can be approached and is being actively studied through classical stochastic models, equilibrium processes, even if we don't have the full solution yet, there is no necessity to introduce the entity of a cosmic visit. It carries zero explanatory power for the fundamental process of like's creation.
You know, it's interesting that the source points out the ultimate irony here. Humanity itself might one day engage in this exact behavior. We might become the cosmic visitors who seed life on other worlds.
Like Carl Sagan's famous proposal to make Venus habitable by propagating Earth algae there.
Exactly.
We may very well become the authors of a future panspermia event. But even our own future actions don't justify introducing that concept as a necessary entity to explain our own past. The scientist who observes an unexplained fact, whether it's stellar or biological, is rigorously bound to search for the universal natural law first. The intervention of reason is the last resort. And usually it's the one that must be rejected.
Okay, so we've established these methodological constraints. Science is obligated to search for the law, not for the designer. And this brings us to the core, almost, tragic dilemma that Lem posits.
Yeah.
If the very structure of science forbids us from accepting intervention, how could a genuine miracle, a real sign of advanced intelligence, ever actually be recognized?
Well, Lem sets the bar incredibly high. For a phenomenon to be recognized as an act of reason, it must involve two things. One, astronomically observable massive power. And two, a mode of behavior that is, however remotely similar to our own logic.
And that definition right there immediately highlights the fatal flaw in our entire search strategy.
It does.
We're looking for ourselves, only bigger and louder. When we search for these miracles, we are searching for phenomena where our own current technological capabilities, especially our obsession with energy and magnitude, are just simply elevated to the highest possible degree.
This is the anthropocentric trap. We project our concept of progress onto the entire cosmos. We define advancement as moving along a single, continuous line of increasing magnitude and power. It's what Lem sarcastically calls the era of big and mighty deeds.
We expect colossal structures, total planetary mastery, maximum energy consumption. The caveman analogy is the most critical insight in this entire section. I think it crystallizes our bias perfectly.
It's a fantastic analogy.
Yeah.
Imagine you go back in time and you ask a Stone Age cave dweller what the ultimate achievement of the future would be. What's the pinnacle of technology?
They wouldn't envision fiber optics or general relativity.
No. They would envision huge, perfectly trimmed flints. They project their current technology, the tool they understand, onto a future perfected state.
And we are doing exactly the same thing today. Our current technological pinnacle involves nuclear power, massive computing, high-energy physics. So therefore, we expect advanced ETI to manifest as Dyson spheres, galactic converters, and maximum energy output.
The Type 3 civilization on the Kardashev scale.
We are looking for the cosmic equivalent of the biggest, most powerful flint possible.
And this projection immediately raises a really deep philosophical question about the nature of civilization itself. Must a truly advanced civilization be defined by its expansive, energetic dominance? Is an advanced civilization the same thing as the most populous one or the most energetically dominant one?
And if the answer to that is no, then a civilization's ultimate state, what Lem calls its sociostasis, should not equate to growing energetic veracity.
Right. Let's define sociostasis here clearly, because it's absolutely central to Lem's critique. Sociostasis is the state of a dynamic societal equilibrium and stability. It implies a condition where the civilization has solved its core internal problems: resource distribution, population balance, ecological integration, internal conflict, all of it. It has achieved an optimal, stable state.
And if they've achieved that optimal state, why would they need to constantly scale up their energy demands? Why conquer new stars and build megastructures?
A stable, successful civilization might logically seek to minimize its resource consumption and its external footprint. Growth, if it happens, would be internal, in terms of knowledge, complexity, internal experience, not external in terms of sheer, brute, energetic conquest of the cosmos.
So the Type 3 civilization, which assumes this perpetual, expansive, heroic conquest of matter, that might just be a technological adolescence, not a maturity.
It might be the sign of a very young, very inefficient civilization. So we are biased toward finding the civilization that hasn't yet learned self-regulation. We're looking for the civilization that is still trying to maximize its energy throughput, just like we are.
Right.
And the source uses a powerful, really visceral analogy to drive this point home. Consider the primitive man by a fire.
The same caveman who wants the biggest flint.
The very same one. He throws everything that can possibly burn into the fire. He's yelling, he's dancing, he's dizzy with the sheer, noisy manifestation of his own power. He is maximizing output, wasting enormous amounts of energy, and celebrating sheer force and volume.
And the unsettling comparison is, are we, with our focus on achieving controlled fusion, building massive atomic reactors, and generating the highest possible energy output for maximum industrial scale.
Yeah.
Are we too much like him?
Are we simply the primitive man writ large, celebrating our own inefficient colossal displays of force?
It's a profound check on our own arrogance. Despite the very real possibility of non-expansive, regulated civilizations, those that have found a steady, efficient state, we have to confess that our entire search methodology is fundamentally restrictive.
We are not looking for all possible civilizations.
No, we are primarily looking for anthropomorphic ones. Those that reflect our current logic, our current definition of success, and our current experimental order. We are seeking phenomena that confirm our notion of what technological progress must look like.
We're looking for the cosmic mirror. And here is the profound final conclusion on bias and expectation. We look diligently for these familiar signs, the massive power, the energetic waste, the colossal manipulation of matter, but we do not observe them.
The famous Fermi paradox, where is everybody?
Lem suggests that this absence, the absence of the expected signal, might not be a failure of existence, but a failure of our imagination. What does it mean that the universe lacks the massive, loud, energetically wasteful signal that we expect to find?
Well, it means either we are truly fundamentally alone, or that the true highest state of civilization transcends the need for big and mighty deeds.
And the stars answer this question with a silence so complete, as Lem says, as if it were eternal. That eternal silence may be the clearest evidence we have that our anthropomorphic expectations, rooted in our own technological infancy, are simply wrong.
We might be listening for the yelling, wasteful man by the fire.
When the mature civilization is quietly optimizing its internal systems,
Yeah.
requiring no external display at all.
This deep dive into Lem's meta-theory of miracles has been a necessary journey, I think, through the constraints of scientific knowledge and the limits of our own human imagination. Let's try to synthesize the 3 critical takeaways for you, the learner, to carry forward.
Okay, first we explored the rare, really fascinating signs of true astroengineering, the ultimate miracles like that technetium calling card, and that showed us that the evidence for vast intelligence might appear, statistically insignificant. It could require just a few million tons of an unstable element to prove deliberate intent, forcing us to view stars as these high-tech, manageable converters.
Second, we fully confronted the necessity and the challenge of Occam's razor. We saw that this principle isn't just about skepticism, it's a mandate. It forces scientists to resist the easy, reasoned intervention answer in favor of seeking a new, unifying natural law.
It's exemplified by that tough choice, right? Finding a new geological law versus just admitting someone placed the stones on the beach.
Exactly. And finally, the really profound critique. Our entire search for ETI is potentially marred by this deep-seated anthropomorphism. We are seeking the image of ourselves, the civilization of big and mighty deeds, defined by growing energy consumption.
And this anthropocentric bias means we may be listening for the sound of a wasteful adolescent, while the universe's true intelligence operates far more subtly, far more efficiently.
This deep dive is crucial because it really shows that managing information overload isn't just about aggregating facts, it's about rigorously checking the rules you use to accept evidence. Just like the scientists looking for a new physical law, we have to resist the temptation to invoke a hidden entity or an easy magical answer when we're faced with true complexity in any area of life.
So here's the final thought. If the highest level of civilization is not defined by raw energy consumption, nor by galactic conquest, but by optimal regulation, profound internal efficiency, and a stable sociostasis, what might an efficiently hidden advanced civilization truly look like?
Could we ever detect a miracle that required no massive power output at all? Perhaps a manipulation of information or consciousness rather than matter and energy? That is the question Lem leaves us with, and it's something for you to ponder as you look up at that silent, seemingly eternal sky.